In the infinite expanse of our cosmos, scientists have discovered thousands of planets beyond our solar system. Each one tells a unique story, but some defy everything we thought we knew about planetary science. To date, we've confirmed over 5,000 exoplanets, with thousands more candidates awaiting verification. But even among these thousands, our top 5 stand out as nature's most extraordinary planetary experiments. Before we begin our journey, let's remember our cosmic address, Earth, our reference point for understanding these alien worlds. Our first stop takes us 63 light-years from Earth to HD 189733b, a planet that would make even the most extreme weather on Earth seem gentle by comparison. This cobalt blue gas giant, similar in size to Jupiter, orbits its star so closely that its atmosphere is heated to an incredible 2,000 degrees Fahrenheit. But it's not just the heat that makes this world extraordinary. Imagine winds howling at speeds of 5,400 miles per hour. That's 7 times the speed of sound on Earth. These winds carry something truly terrifying: glass rain. Yes, you heard that correctly. Actual molten glass, condensed into microscopic shards, raining sideways through the atmosphere. The planet's striking blue color isn't from oceans like Earth, but rather comes from light scattering through a hazy, turbulent atmosphere. This atmosphere is so thick and dynamic that it creates one of the most violent weather systems ever observed. The more we study HD 189733b, the more it challenges our understanding of what's possible in planetary weather systems. Its existence proves that nature can create conditions far more extreme than anything we experience on Earth. And this is just our first weird world. We're just getting started. Our next destination is perhaps the most valuable planet in the universe, if you could ever reach it. PSR J1719-1438. B isn't just a planet with diamonds, it essentially is a diamond. But its origin story is even more fascinating than its composition. This planet began its life as a star. Yes, you heard that correctly. It was once part of a binary star system, orbiting alongside a pulsar. But over millions of years, the pulsar's intense gravitational pull stripped away its companion's outer layers, leaving behind something extraordinary. What remained was primarily carbon, the same element that makes up diamonds on Earth. Under the incredible pressure and density of this stellar remnant, that carbon crystallized. The result? A planet-sized diamond floating in space. To understand just how dense this world is, consider this. A teaspoon of its material would weigh several tons. Its surface gravity would crush any spacecraft attempting to land. The entire planet is compressed into a crystalline structure that would make Earth's diamonds seem like cheap imitations. The planet orbits its pulsar so closely that a year there lasts just 2 hours. The radiation from the pulsar would be lethal to any form of life we know. But it creates a spectacular light show as it interacts with the crystalline surface. PSR J1719-1438b represents one of the most exotic end states possible for a stellar object. It's a glimpse into the future of some binary star systems, and a reminder that in space, even stars can be transformed into something completely different. This cosmic diamond will likely outlast many of the stars we see in the night sky. Imagine a world so dark it makes a moonless night look bright in comparison. TRES 2b holds the title of the darkest known planet in the universe, reflecting less than 1% of the light that hits its surface. That's darker than black acrylic paint, darker than coal. This planet is practically invisible. To put this in perspective, even the darkest materials we use on Earth reflect several times more light than TRES 2b. Its atmosphere is composed of light-absorbing chemicals, like vaporized sodium and potassium, creating an almost perfect black body. Located about 750 light-years from Earth, this dark giant orbits so close to its star that its temperature soars to over 1,800 degrees Fahrenheit. Yet despite this intense heat and radiation, it somehow maintains its ultra-dark appearance. Scientists believe that the extreme heat prevents clouds from forming, which might otherwise reflect light. Instead, the atmosphere is a cocktail of light-absorbing molecules and superheated gases that create this unprecedented darkness. The planet is so dark that it's only visible because of a faint red glow from its intense heat, like a piece of metal just beginning to heat up. If you could somehow survive on its surface, you'd be standing on a world that seems to swallow light itself. TRES 2b challenges our understanding of planetary atmospheres and demonstrates that even something as fundamental as a planet's brightness can reach extremes we never imagined possible. It's a reminder that the universe has many more surprises in store for us. Our next planet is literally being torn apart before our eyes. WASP-12b is dying, and its death is spectacular. This gas giant is so close to its star that the star's gravitational forces are literally pulling the planet apart piece by piece. The intense gravitational forces have stretched WASP-12b into an egg shape, but that's just the beginning. The planet is losing mass at an incredible rate. 6 billion metric tons every second are being stripped away into space. The intense gravitational forces have stretched WASP-12b into an egg shape, but that's just the beginning. The planet is losing mass at an incredible rate. 6 billion metric tons every second are being stripped away into space. To put that in perspective, this means WASP-12b is losing the equivalent of Earth's entire atmosphere every 10 days. Astronomers estimate that at this rate, the planet will be completely devoured by its star in just a few million years, a mere blink in cosmic time. The star's pull is so strong that it's created a visible stream of matter flowing from the planet to the star. This material forms a disk around the star, like water spiraling down a cosmic drain. We're witnessing planetary destruction in real time. The planet's rapid orbital period, just 26 hours to circle its star, means we can observe dramatic changes in relatively short periods. Each orbit brings another wave of destruction as the star's gravity continues its relentless pull. WASP-12b provides astronomers with a unique opportunity to study how planets die. It's a glimpse into the possible fate of other worlds that venture too close to their stars, and a reminder of the powerful forces at work in our universe. Our final destination is 55 Cancri E, a planet that combines several extreme features into one bizarre world. This super-Earth is believed to have a surface made of diamond and graphite, but unlike our previous diamond world, this one is scorching hot. One side of the planet eternally faces its star, creating a permanent day side where the heat is intense enough to melt and vaporize diamonds. The other side, while cooler, still reaches temperatures that would melt lead. With surface temperatures reaching 3,900 degrees Fahrenheit, any diamonds here would exist in exotic states we can barely understand. The planet's year lasts just 18 hours, as it races around its star in a perpetual orbit of extreme heat. What makes this world particularly interesting is that it challenges our understanding of planet formation. Its high density and carbon-rich composition suggest it formed under conditions very different from Earth, possibly from the remains of a carbon-rich star. These 5 worlds represent just a tiny sample of the extraordinary diversity of planets in our galaxy. From glass storms to diamond worlds, from planets darker than coal to worlds being torn apart by their stars, each one challenges our understanding of what's possible in nature. As we continue to explore the cosmos, we're sure to find even more bizarre and fascinating worlds. Each discovery reminds us that the universe is not only stranger than we imagine, it's stranger than we can imagine. Thank you for watching. Make sure you subscribe for more interesting space videos weekly.